Hello guys, a good day. Welcome once again to my channel. Okay, so we are now on a learning session 5 in our project construction and management subject. This learning session is entitled The Network Fundamentals. Okay, so this one guys is used in a CPM or in PERT in project monitoring. Okay, so let us go to our presentation. Okay, so for this one, for our introduction, we have network conventions. Okay, so network diagram is composed of a number of arrows and nodes. Okay, so arrows are typical arrows and nodes are circle or other geometrical form which is used in the diagram. Okay, so then we have two different kind of conventions. We have activity on arrow, which is AOE, using arrows to designate activities, and we have EON, which is activity on node, using nodes to designate activities. Okay, so this is the diagram for AOE. This one is the activity on arrow. Then this one is activity on node. So node are these circles. Okay, so nodes in the AOE represent the beginning and the end of the activities, which is called event. Okay, then events are point in time. Then activities can be referred in two ways. We have by endpoints such as activity 1-2. Example is this one activity 1-2. Then later assigned to an arrow such as activity A, B, or C, and so on. Okay, so example for that one, if we can denote this arrow as A, so that's is called activity A. Okay. Then a network describes a sequential relationship. Example, activity 2-3 cannot be started if activity 1-2 has been completed. So this is one of the major use of this networking or network or using a project network, because we can know what activity must be done first. Okay, then we have the elements of a network diagramming. Okay, work B, for this one, work B cannot start until after work A is completed. Okay, so this one, so this work cannot be so work B, this one cannot be start if this activity is fully done or completed. Okay. Then we have C cannot start until both A and B are completed. See, this is the diagram. Meaning we have to complete these two activities before this activity. Okay. Then we have A must be completed before either B or C can start. Okay. This is the diagram. This must be completed first before we can start activity B and C. Okay. Okay, so we have this diagram. Both A and C must be completed before either B or D can start. Okay, so this is the diagram. Then we have both A and B must be completed before C can start. Okay, so this one. And D depends only on B and A. X is called dummy. Okay, so we have a dummy activity. Okay, so we can learn dummy in the next learning sessions. Then D depends on A and B. Okay, then C depends on only A. Y is a dummy. Okay, so meaning D depends on A and B. Then C depends only on A. Okay. Okay, we have the principles in network or arrow diagram. Okay, so we have principle number 1, that everything in the network or arrow diagram must have a meaning. Okay, so example for this one is every arrow represents an item or work and is called an activity. Okay, one arrow means one activity. Example are this one, excavation. Okay, then this is part of principle number 1. Letter B. An event is the starting point of an activity represented by circle. So this one. square, or any geometrical form. Okay, so you can use other forms, but the most common used form for this one is circle. Okay. Then letter C, for principle number 1, we have an activity is dependent upon and cannot begin until after the completion of all preceding activities. Okay, so like this diagram, this is the preceding activities for pouring footing slab. Meaning, you cannot pour the footing slab without making forms and order and deliver cement. Okay? Okay, so letter D, part of principle number 1, all activities that start with the same event cannot begin until after the completion of all activities that enter that event. Okay, so meaning for footing slab and for pedestal cannot start before the completion of these two activities. Okay, so we have letter E in principle number 1. The three activities of sticking, butterboards, and diggings, okay, so these activities on arrow, which start from event 5, must wait until activities entering event 5 is completed. Okay, so meaning we have to finish first the building permit and clearing the site before we can conduct staking, butterboards, and digging. Okay. So we are now on principle number 2, that an activity has a single definite starting point and a single definite ending point. Okay, so this is the diagram, the sample diagram. We have activity on digging, this one, worms. Then after event 3, we have two activities here. We have wall footing and floor footing, then block laying. Okay. So we are now on principle number 3, that network or arrow diagram does not describe time relationship but rather dependency relationship. Okay? So the dependency of activities, not time. Okay, for principle number 4, that the network or arrow diagram is hardly ever done by a single person. Okay, so meaning of this principle is that when we are preparing the PERT CPM for a certain project, it is very essential that we call the people who are experienced, especially those people who are directly connected on site. Okay, so because they are the one who knows the actual work or job. Okay, so the accomplishment of the schedule made in the program is influenced by several number of people who have something to do with the project. Okay, so we are now on the fundamental elements of PERT, CPM, and networking. Okay, so the fundamental elements of PERT CPM networking activities are as follows. Okay, so we have activity, event, and time. Okay, then activity, it is defined as the work operations required to complete a task, the actual work between events. Okay. Then for events, we have point in time, signifying the beginning or end of one or more activities. Okay? Activities can either be by their endpoints, such as 1 dash 2, 2 dash 4, etc. Example, 4 dash 6, 4 dash 6, then 1 dash 3, then 3 dash 5. Okay? Number 2, by letter assigned to an arrow such as A, B, C. Okay, D, F, E, G. Okay. We have dummy activity. Okay, so dummy activity defines as an arrow on a network showing the dependent relationship between two activities. Okay. However, dummy does not represent actual work efforts and do not consume time. Dummy activity may be used in the network to distinguish between two or more parallel activities. Okay. Okay, so we have duration of an activity. This is defined as the time it takes on activity to be finished. Okay. In short, this is the normal time duration of the task. Okay. Then a duration activity is the span of time from the early start to early finish, from its late start to its late finish. Okay. Okay, so we are now on path. So a path is a sequence of activities that leads from the starting node to finishing node. Okay. So example for this one, for this network, we have two paths. Okay, so path number 1, number 2, number 4, and number 6. Okay, the other path is 1, 3, 5, and 6. Okay, so these are the two paths of this network. So the the path inserted with blue line, dotted line, and the red line. Okay, so these are the two paths for this activity. Okay. Then we have rules for numbering events in network diagram. Okay, so in making this diagram, we follow a certain rule. Okay, so this is to make our life easier in making this one. Okay, so number 1 rule is all events should be numbered starting from left to right. Okay, then number 2, no event number should be lower than the number of event preceding it. Okay, left to right direction also. Okay, so meaning if you numbered 1 here, so 2 going to right, so 2, 3. Okay, so number 3 is event number shall increase from left to right. Then number 4, events should be numbered from bottom to top. Okay. We should remember these rules because this is the rules also when we are reading or analyzing a certain diagram. Okay. Okay. So like this one. Okay. So we have a network which shows this is node 1 or event 1. Then we have 1, 2, 3, 4 activities after event 1. Okay, so let's see. Okay, so example, we have A. Sorry, so this is for the example. Okay, so this is the diagram for the roles. Okay, so if you can observe, the event should be numbered starting from left to right. Okay, so you can observe this event 1, left to right. Then from top to bottom, number 1, number 2, number 3, number 4. Okay, so let's check another rule. Event number shall increase from left to right. Okay, so it increases from left to right. 1, 2, 3, 4, 5. Good. Then, sorry, this is example. Number 4, events should be numbered from bottom to top. Okay? Okay. Okay, so we are now on the example. Okay, so let's try to make this from this tabulated data. Let's try to make a diagram. Okay, so we have A, activity A, C, D, B, E, F, I, G, K, H, K. Okay, so if you can observe, guys, activity A precedes CB. Okay, then activity E precedes F, then activity G precedes H. Okay, so if we draw this one, Okay, start. This is the start. Wait, sorry guys. Okay, so I plan to make this one here, but I think we cannot do on the reading mode. Let's try in the normal. Okay, so okay. Okay, I hope you can still see this one. Okay, so I try to adjust. Just adjust it. Okay, so I'm having trouble in way. I think the pixel is not good. Okay, let's try this one. So let's check. Okay. Um, Wait. Let's try to fix this one because. Okay. Okay. Okay, so I am having a problem with the computer, guys. So maybe I will upload another video for the example. Maybe I will use pen because I'm having problem. One, let's try. Okay. Okay, sorry guys, I have some technical problems in here. Okay, so maybe I will just post my example on my next video for this one. Okay, so maybe I will try to fix this one first. Okay, so thank you guys for watching. This is all for learning session number 5. Okay, so our next learning session is all about, okay, let's see. the network diagram. Okay, so we are done in the network fundamentals. Then our next topic is on the network diagram. Okay, so thank you guys. So I will upload or discuss the example in my next video. I will try to fix some things in my one presentation and in my computer. Thank you for listening, and that's all for learning session number 5. Thank you.